In this video, we'll take a look at section number 3, problems 3 and 4. So problem 3, we're looking at this and we're about to look at a migration, mobility, immigration issue. And we're saying that initially the Utah economy is in equilibrium. It's got the following labor supply relations. Labor supply is equal to 150,000 plus 250W. And labor demand is equal to 1,900,000 minus 220W, where W is the monthly wage, that might be important, and L is the number of workers. We then say there's a surge in high-tech development which motivates workers to move into the state, such that the labor supply increases by 50,000 at any wage level. So if you think about that, if we look at our curve here and we have a labor supply curve, if it increases by 50,000 at any wage level, that is simply a parallel shift outward to some new labor supply relation. So I first asked the question, what are the equilibrium wage and labor levels in this market before high-tech development appears? Well, we look at the original labor supply, original labor demand, and go ahead and equilibrate them in the normal fashion. We then end up with a W star of 3723.4. That's a monthly wage. And then we end up with 1,080,852 workers. Most of you that tackled this did it either just dead on or you got some of your math a little bit wrong. I saw some people that subtracted 220W or went ahead and added 150. You just did the math a little bit wrong. You ended up with some skewed numbers. So for B, what's the new labor supply equation given the influx of workers? Well, we have the original labor supply equation, 150 plus 250W, and we know that at any wage there is an additional 50,000, so we simply add that, which gives us the new labor supply of 200,000 plus 250W, which would be indicative of a labor supply equation that's gone from LS to something like LS prime. In part C, we say, what are the market clearing levels of wage and labor following the influx? So now we're going to take the new labor supply equation, equilibrate it against the original existing labor demand equation, and we're going to see that when we do this in the regular way, as we've done many times now, we end up with a decrease in the wage, which makes sense to us. If we have a labor demand curve coming through here that looks anything like this, well, we would expect wages would have decreased and workers would have increased. So we end up at 3,617 in the wage, and that's a monthly again, and 1,104,255.6 workers. If you were anything close to these, then you were okay with me on this. Maybe if you were off just a little bit, it was a rounding error. Move on to part D then. I'm asking you to model this. And we're doing this exactly as we've done it before. You can see some of my numbers down here. If you want to go through them, you want to pause this video, look at them carefully. Hopefully you can read them. Most of you did this just fine that did this. If you knew what you were talking about, a few of you were just guessing, and that's a little bit dangerous on these, of course. But I was looking for each one of these variables and levels to be measured and labeled. And you would expect that with the two different labor supply curves, some labor demand curve. Nothing has changed in the labor demand. I did have a few of you give me two labor demand curves and one labor supply, even though it was supply that was changing, not demand. I was specific about that. Had a few of you give me no labor demand, but a marginal revenue product of labor curve here, and one labor supply and a marginal expense of labor, as though this was a monopsony scenario. I don't know how you got that interpretation, but some of you did. It just didn't use the proper information from the story that we're building here. So that's part D. And then part E, I said, okay, offer some rationale as to why the reduction in wages seen by motivating the labor supply and demand equations might not result in the outcomes that we originally calculated. Well, we know that if additional labor supply moves into a market, that means that there's new people in that market demanding new goods and services in that market. So there's probably some articulated increase in labor demand as well, which would perhaps then bring the equilibrium wage either back to its original level or something close to it. at a higher number of workers. And we've talked about this in the modules before, in the review problems, I think even in the Canvas discussions. So that's what I was looking for there. That if there's going to be an increase in labor supply, then there's also going to be an increase in the demand for goods and services, which begats an increase in labor demand for the companies that manufacture those goods and services. So that's the argument that we would say really contradicts the mainstream and very limited view of this. It's the next step in the evolution of this, of course. And that should have been obvious to you by now. It was for most of you that took this on. Finally, in question number 4, part 3. Now we're looking at 2 different types of workers in a given labor market. We're saying that one is a low-skilled worker, and they receive a relatively low wage, which we would expect. Another is a high-skilled worker, and they received a high wage, again, which we expect, and we're going to call them high and low. And I say the minimum wage is 7.25 in this market. L is equal to the number of workers in hundreds. Low has a labor demand schedule parameterized by LD low of 60 minus 5W of low. High labor demand is LD high equals 75 minus wage of high. And labor supply for either type of worker, for both types of workers, is 8W minus 35. Or you might have thought of that as negative 35 plus 8W. So first we're going to identify the own wage elasticity for workers at each firm. Remember, own wage elasticity is this funky little n being equal to percent change in L for worker I divided by a percent change in W also for worker I. Okay? And we know where our starting position is here for each of them because we have a supply and a demand equation for each type. So we go ahead and put for low, labor supply equal labor demand, brings us to a W1 of, or a W star of 731 and an L star of 23.46. We can think of those as W1 and L1. And then I say, consider the elasticity here when the wage increases by 1.5. So W goes from 731 to 8.81. Which begats a change in L2. And here again, you've got to use demand because this is the labor demand elasticity. So if we have increased the wage, we expect to decrease the number of workers. And so here we've gone from 23.46 at L1 to 15.95 at L2. But now I've asked you to use, I believe it is the simple equation again. And so just do the math on this the normal way. So we're taking the percent change, which is L2 minus L1 divided by L1, divided by W2 minus W1 divided by W1, which is going to give us negative 7.51 divided by 23.46. So, and then that divided by 1.5. That was the change, of course, in wage that we told you, divided by 7.31, the original wage level. Well, I then go ahead and invert the denominator because I like to use a product rather than a quotient. You don't need to do that. It's just simply a personal preference, such that we end up with negative 1.56 for the elasticity quotient, and that is elastic, of course. And that's what we would have expected for the low-skilled workers. We do the exact same thing with the exact same metrics for the high-skilled workers, and we end up with a elasticity of negative 0.1926, and that is inelastic. Again, you're just using the simple formula. If you want to pause the video to look at my math here, I came about these, you'll see exactly where we are. But I created a W1 from W star, an L1 from L star, and then a W2 by expanding W1 of 12.22 to 13.72. That's a 1.5 expansion, exactly as I've suggested right here. And then we go ahead and identify the new level of labor, which you would expect to be a reduction at a higher wage. And it's not much of a reduction because it ends up being a relatively inelastic, in fact, frankly, a very inelastic worker. So then I said, okay, based on the types of elasticities you've identified, what would you expect to happen to the total wage bill for each of the two firms employing these two types of workers in the event of the wage increase? What I was hoping you would do is give me the basic rule that I taught you in the modules, that if it's elastic, when wage increases, the total wage bill goes down. Inelastic, wage increases, the total wage bill goes up. Total wage bill is synonymous with total cost of labor. I then expected you, based upon what I've asked for here, to not only give me the rule, perhaps, but show it, prove it. So W1 times L1 was equal to 171.49. W2 times L2 was equal to 140.51. Well, as wage rose, total cost of labor declined. I did the same thing for the high level of labor, and we simply validated that the rules were accurate. Then in part C, I said, suppose that the wage increase for low resulted in a cross-wage elasticity. So remember, cross-wage elasticity is the percent change in for LI, worker I, divided by a percent change in wage for worker J. So I've said if that's positive, so it's greater than 0, well, that's going to beget a substitute. Excuse me, going to become a substitute. Think this through. If the wage for worker J goes up, I know that the labor demanded for worker J is going to go down because we have downward sloping labor demand curve. And if in order for this to end up being positive or greater than 0, based upon the wage of J going up, that means the labor for I has to go up. That way it becomes a positive term. In which case, if the labor for J goes down and the labor for I goes up, they are substitutes for each other. Many of you, more than half I believe, said these were complements. If you think about this, if it's a complement, as the wage for J goes up, the labor for J goes down, and if it's a complement, then the labor for I would also go down, in which case this term would have been negative or less than 0. So you didn't walk through it. And I think I've told most of you, in fact, I know I've done this in one of the videos, always walk through these. Don't just memorize these things. Walk through them step by step. Even though I've done these now probably thousands of times, I still walk through this kind of a scenario step by step. Just as I do here in item B. I take out my rule from what I've memorized, and then I validate through the numbers whether the rule made sense. So as I go to item D, now I ask you, does the elasticity value and type you calculated in part A change if we use the midpoint formula? Remember, the midpoint formula is, the midpoint formula is going to be L2 minus L1 divided by L2 times, plus L1 divided by 2, and that's going to be divided by W2 minus W1 divided by W2 plus W1 divided by 2. So it's a slightly more complicated form of the labor demand elasticity, and we use it when we want this to be a little bit more accurate. And in this case, does applying this formula give us a different type of elasticity as we have a slightly more accurate value? Well, if you follow the math through, and if you'd like to pause this to look at it, as you follow the math through, you see that for low skill level workers, we become a little bit more elastic, but we're still elastic. And for the high skill workers, our inelasticity becomes a little bit higher as well, if you come back to our original numbers. But they're still elastic and inelastic. So we just proved that. And then finally, I ask you to, in simple but illustrative terms, explain the concept of labor demand elasticity. And what I've said here, I think, is a pretty simple way of saying it. Elasticity represents the change in one variable as a result of the change in another. You can use the rubber band and a piece of wood, or in this case, we're using labor and wage. And so in labor demand, this is the change in labor in response to a change in wage. We expect the value of this term, I give you the term here, to be less than 0 because it's demand. And since labor demand is negatively sloped. And if we used a cross-wage elasticity rather than this own wage elasticity, then it's a slightly different equation, and we would expect substitutes to be greater than 0 and complements to be less than 0. Now that's a fairly complete definition. If you gave me anything that was close to that, you got most of the points here, if not all of them. If you gave me something that was at least this complete, you got all of them. Some of you gave me some really interesting answers that I was entertained by, but they didn't really explain labor demand elasticity necessarily. And that is question number 4.